Hello and welcome, dear friends. In this video we will continue to learn how to determine the optimal path. We already know how to determine the distance to any hex. Let's continue. Let me open the battle hex script. I will create a new method and name it define me as starting hex. I'm not going to change anything, I'm going to make the code more readable. To define a hex as the starting position, I just need to add two lines. The first line changes the value of the isStartingHex variable. The second line is necessary in case the hero stands on the desert or swamp hex, so that the first step takes only 1 unit of the hero's velocity. The swamp will stop moving, but a hero will be able to get out of the hex if the swamp is a starting hex. And instead of extra lines, I will call the method using the reference to the starting hex. Good. Now, if we want to adjust the behavior of the starting hex, then we adjust a method instead of a bunch of scattered lines. Now a few words about how we determine the optimal path after the player selects the target position. Go back to Unity and run the play mode again. So we can set all possible positions, we can click on target hex and we see the distance between the starting hex and the target hex. Each hex displays the distance to the starting hex. Well, the target hex is already known. We highlight it by clicking. Let the target position be one of the positions on the edge of the possible area. How a hero can get to this position? Obviously, the fewer steps we use to reach a hex, the shorter the way we get. A hero cannot get to the hex from an object whose distance from the starting point is greater than or equal to the distance from the starting point of a target hex. In this case, a hero must take one more step, and a number of steps will be bigger than the distance from the starting point of a target hex. This means that we haven't chosen the shortest path. We will need to use 4 steps to this hex and take another step to reach the target hex, and it makes 5 hex in total. Obviously, a hero gets there from one of the positions whose distance from starting point is 1 less. It doesn't matter which of 2 positions was the previous one. All that matters is that the value of its distance from starting point variable is 1 less than the value of the same variable of the target hex. We can apply the same logic for the adjacent hex. A hero reaches this position from the one whose distance from starting point variable is 1 less, and so on until the starting point is reached. Yes, there are several shortest paths, but we don't care which one will be chosen by a hero because only its final position is important. Well, that sounds like pretty good code logic. Let's try to implement it. Okay, we have ifItisNewHex method that checks if certain conditions are met. The behavior of the method helps to determine all possible positions. To determine the optimal path, we need the ifItisNewHex method to behave a little differently. Besides, we will need to determine the behavior of PC enemy. An enemy looks for a target to strike without player clicks on hexes. It will be a completely different behavior, and we must be prepared for this. We don't yet know how to do this, but multiple behaviors give a good reason to use interfaces. Let's practice. AvailablePosition class using the getAvailablePositions method determines all possible positions. To determine all possible positions, the method uses IAJSONFinder interface. The interface allows us to change the behavior of the method depending on the type of a hero. The getAvailablePositions method works for both ground units and flying units. The method using the interface calls getAdjacentHexesExtended method. GetAdjacentHexesExtended method calls getAdjacentHexes method that is a member of NeighborsFinder script. GetAdjacentHexes uses the ifItisNewHex method. Here we are going to modify the structure and make the structure more difficult, but more flexible and editable. Flexibility is important not to add a large number of if statements. And if we need to edit anything, it will be easier to find a class and a member to refactor it. It is always a matter of choice. I will opt for code flexibility. First, I will add position4path script that implements the IAJSONFinder script, and using the getAdjacentHexesExtended method, the script will look for hexes that become a part of an optimal path. Then I will create an interface and name it iEvaluateHex, I will create 2 more scripts that will implement the interface. I will name this first script as well as the method that we already use. I will name it IfItIsNewHex. We will not change anything else. The methods will do the same. The second script using the interface will help us to determine the optimal path. I will name it IfItIsOptimalPath. It will also evaluate the hex, but this time the method will have different behavior. This structure doesn't make much sense in this form, but here we can add any behavior whenever we need it, for any tasks, and it's very convenient. Let's do it. I will start by creating a folder and a new script. This script will determine the optimal path that we consider the shortest way to the target hex. Therefore, I will name it simply. It's going to be an optimal path script, and I will attach it to the hero prefab. Let me create 3 more scripts. The first one will be an interface. Name it iEvaluateHex, and 2 scripts, IfItIsNewHex and IfItIsOptimalPath, will implement the interface. I will name the last script PositionForPath. The script will implement the iAdjacentFinder interface, and using the getAdjacentHexes extended method, will look for an optimal path. Scripts are created, and now we are going to jump from one script to another. Open the optimal path script, delete the update function, and let's create a public method and name it matchPath. It returns nothing. I can use one parameter to identify which hex is a target hex now. However, this time I will not use parameters, just to show another way. Now we can highlight target hexes, and the starting hex is also defined. However, other scripts still do not see these objects. I need to create a variable that will store data related to the target hex and to hero whose turn has come, so that I can refer from other scripts to those variables when I need them. I will open the battle controller script, so here I will add 2 public static variables. Current attacker is of hero type, target hex is of battle hex type. Inside the start function, I will look for only hero I have now. For this purpose, I will use the findObjectOfType method. Now let me assign an object to target hex variable. Go to battle hex script. I have a method that defines the target hex. It is makeMeTargetToMove method. I will change the value of the target hex variable every time I click on the hex. Here I can assign an object to the target hex variable. Since the variable is public static, I will write the name of a class and the name of a variable. To assign an object, I will use a new keyword. I will write this. The keyword refers to the current instance of the class. In fact, it is a reference to the object to which the script is attached. That is, when I click on the concrete hex, I say that this instance of battle hex object is being clicked. I will open the distance class. I need a method that will compare values of distances from the starting point between 2 hexes, the initial hex and the neighboring one. The method returns boolean. It says that if the distance from starting point of neighboring hex is less by 1, then it is a part of optimal path. Instead of 1, I use the value of the steps to go variable. Remember that we have desert and swamp hexes that slow down the movement. For example, we have neighboring hexes with different values of distance from starting point variable. In this case, the forest hex will be selected as a part of optimal path, since its properties correspond to the formula. I hope it's clear. We need to save the result of this comparison somewhere. Open the optimal path class. I will activate the only variable. It is public static next step variable. The variable will store information about the new part of the optimal path chain. Each time we find a new link, we will update the value of the variable. Let's continue by creating an interface. Go to iEvaluateHex script. Let me write an interface instead of a class, and add one single method. The method returns boolean, name it evaluateHex, and the method will have only one parameter of battle hex type. I will pass the evaluated hex into the method. Let's implement the interface. Open the IfItIsNewHex class. Here I will copy the same logic that we used inside the IfItIsNewHex method. That is a member of NeighborsFinder class. This doesn't change anything yet, just added an intermediary. open the IfItIsOptimalPath script. In this class I will do the same, except that I will not evaluate the hex if it is starting one. I will not need that. In this case I will use a different logic. I will evaluate the hex if it is neighboring one, meaning that its neighboring hex variable is equal to true. I don't need to check other values, since if the hex is neighboring one, it must be active. So we have created the bottom part of a new structure. Now let's proceed with PositionForPath class that implements the IAdjacentFinder interface. I have implemented the interface so that I'm forced to create getAdjacentHexes extended method. The method looks for a hex that will become a link in the optimal path. Let's move line by line. Check hex variable refers to the IfItIsOptimalPath class. Using the variable, I'm going to pass a new parameter into the getAdjacentHexes method. The neighbors2check list collects adjacent hexes for the evaluated hex. GetAdjacentHexes method this time collects only hexes whose neighboring variable is true, since we have created another behavior. We haven't created the parameter yet, so for a while we will see an error. It is not a problem, we will fix it soon. For each hex in neighbors2check list, we evaluate the value of distance from starting point variable. For this purpose, I use the method we recently created. If the comparison result is true, then we found a hex that becomes a part of an optimal path. If I found one hex among the neighboring ones, then we don't need to look for others. So I break the code execution using the break keyword. Next time I will execute the code for the hex we just found. And this loop should be repeated until we reach the starting point. To let C# know which hex has become part of the optimal path, I use the reference to the next step variable. Next time we run the getAdjacentHexes method, the initial hex will become the hex which is stored in the next step variable. I hope it makes sense to you. If it doesn't, please don't worry. We will use these members many times, so it will become absolutely clear. Now let's fix an error. Go to implementation of getAdjacentHexes method and add a new parameter. It's going to be of IEvaluated hex type. I need to make another change. I will use checkHex variable as a reference to call evaluateHex method. Now the execution depends on the option defined by the interface. I will delete the method we don't use anymore. Good. To complete the adjustment, open PositionsForFlying script. PositionsForFlying and PositionsForGround classes use the getAdjacentHexes method. So we need to pass a parameter into the method. Before that, I need to define the behavior of evaluateHex method. This time I need the same behavior as before. So I have created the instance of IfItIsNewHex class. Having this reference, I can call the evaluateHex method with behavior we need. The same thing I have to do for PositionsForGround class. Initialize the variable of IEvaluateHex type and pass it into the method. Good. 2/3 of the work done. Now open the OptimalPath class. It is time to activate and explain the statements I have written here. This class uses the classes and members we have created. It looks for the optimal path and collects all hexes of an optimal path in one list. The optimal path list is initialized to collect those hexes. Remember that the optimal path script is a component of the hero object. The next step variable will store information about the hex that is just included in the optimal path. The target hex is the clicked hex. We define it as a target position. The adjacent option is initialized by the PositionsForPath option. This class looks for adjacent hexes determining the optimal path. Let's proceed with the matchPath methods. First line passes information about the target hex to the method. The target hex will be the first hex that I will include in list. This also will be the last position of hero's movement. Now I can start the for loop. How many times should I iterate the loop? Well, let's think about it. If the distance from the starting point variable is equal to 1, then we don't need to call the getAdjacentHexes extended method at all. In this case, the target hex is the only element of the optimal path. so we don't need to look for other positions. If the distance from the starting point variable is equal to 2, then we need to call the method only once, to find the hex which is between the target hex and starting hex, and so on. The algorithm is clear. So the first value of the loop variable will be equal to the value of the steps variable. And the last value is going to be bigger than 1, because we don't need to find adjacent hexes when we have only one step to take. Since we count from the maximum value, the value of the variable should decrease to get the minimum possible value. I will create a method that will reduce the number of steps. The method will return a number that reduces the number of steps. It can be just 1, since we have desert and swamp hexes. I will create the makeMe part of the optimal path method inside the distance class. Here I will return the value of steps to go variable. The first statement adds hex to the optimal path. The second statement temporarily changes the color of landscape object, just to check if an optimal path is defined correctly. Open the optimal path class again. What is going on during the first iteration? When we call the getAdjacentHexes extended method, we set a new object to the next step variable. Now it is a hex that is one of the elements of the optimal path. During the next iteration, it has to become a target hex, so that we'll able to find the next element of the optimal path. That's why target hex is equal to next step. When the second iteration begins, we will look for neighbors for the hex defined as a result of the first iteration. And so it will continue until the value of the I variable is greater than 1. Using the methods, I will highlight the color of its landscape object. And now we need to call the matchPath method somewhere. Well, we call it when we click on hex. So go to the ClickOnMe class. The optimal path class is a component of the hero object now. We know where we can get a reference to the hero object. It is current attacker variable, the member of battle controller class. So I will find the optimal path class using the getComponent method. And referring to the optimal path class, I will call the method. Good. Finally, I can check how it goes in Unity, save the current progress, and go to Unity. Press the play button. When I click on a hex, the optimal path is highlighted. Good. Now we can breathe a sigh of relief. We cleaned up the code and finally determined the optimal path for movement. It wasn't easy, however, we have an editable structure. In the upcoming video, a hero will finally start moving. Great job! See you in the upcoming video.